So we've got an extra special guest for you now, Sébastien, who's one of the DevRel at AWS. He's going to demonstrate how to leverage the KMS, AWS KMS to work alongside MongoDB's client-side field-level encryption. So show of hands in the audience of those that are familiar with client-side field-level encryption in MongoDB today already. Okay.
One gentleman over there.
So client-side field-level encryption by MongoDB was a 3-year, if not longer, project with some of the biggest brains in crypto and ciphers to solve a problem and giving confidence to organizations about putting their data in the cloud, making sure that data they saw to be very sensitive would be encrypted on the client side, and there would be absolutely no possible physical way of being able to access or decrypt that data anywhere else. So if you didn't have access to your own client-side key, you wouldn't have access to that data. And that obviously leads into a lot of tick boxes around compliance, governance, GDPR, etc. So that's the philosophy of client-side field-level encryption, but I'll let Sébastien go into the detail of how to leverage that. Thank you.
Thank you, everybody. Welcome to this talk. Thank you for being here in the afternoon. As Matthew introduced me, I'm going to talk about different ways that you can leverage to integrate your AWS account with MongoDB and specifically MongoDB Atlas. And I'm going to talk about two different things, the network level integration between AWS and MongoDB Atlas, and then the key management, and I will show us an example client-side encryption. So I hope you are well seated because it's quite a lot of technicity and technicalities. I have a lot of code as well to show you today in the slides. So let's start with the security of the network. Typically when you want to access MongoDB Atlas, you need to filter on some kind of data so that only your application is able to access MongoDB Atlas. And the old way to do that is probably to use filters on IP addresses, but that's from last century. In the 21st century, you cannot really configure firewalls and rely on IP address. IP addresses are changing all the time. Think about an AWS Lambda function, for example. Every Lambda function will have a different IP address. Think about your containers, it's the same. And even a good old virtual machine, an EC2 instance, if it's scale out, scale in, the IP address might change. So there must be a better way than just filtering on the IP address to protect the access to MongoDB Atlas. And the way to do that with AWS is to use a service in VPC called AWS VPC Private Link. So a private link, it's a private connection, as the name implies, between your network on your AWS account and the network of MongoDB Atlas that also runs on AWS. Thank you, MongoDB, for that. So it's a bit like if you pull a cable inside the data center where your virtual machines are running on your account, and you pull the cable back to MongoDB Atlas. And you have a cable and a direct network connection in between the two. We are in the cloud, so the cable is not real, it's a virtual cable, but the concept applies exactly. So when you create a private link, you also need to create an endpoint on your network. And that endpoint, it's like the DNS name, the IP address, where your application can connect to communicate with MongoDB Atlas. And that communication is one way only, so even if you establish the connection between your VPC and the one from MongoDB Atlas, there is no way for MongoDB to initiate a connection back to your VPC. So let's see how it works, and I'm switching to the MongoDB Atlas console here. I navigate to network access and then private endpoint. You will see that just on the left of private endpoint, there is also peering. Peering, it's a two-way communication. It's bi-directional communication between the two networks. That's not what we want here. Here I want to be able to initiate my connection from my VPC, from my AWS network, to MongoDB Atlas. So private endpoint, add a private endpoint. Then of course I choose where I want to connect to. In this case, it will be AWS. I choose a region. For this demo, I selected Paris because I prepared the demo for MongoDB.local event in Paris a few months ago. And once I have the region, I enter the ID of my network on my AWS account, my VPC ID, and my subnet ID. MongoDB doesn't need that. It's just to make your life easier because they generate the command line that you have to type on your account, on your machine, to prepare your side of the VPC endpoint. So you just enter these two, and the command line is ready for you to copy at the bottom on the screen. If you do not know where to find these VPC ID and subnet ID, you go to the AWS console. Inside your VPC console or EC2 console, you can find the VPC ID and the subnet IDs where you need to connect to. I copy the CLI provided by the MongoDB Atlas console. So I open a terminal on my laptop and I paste the command line with the region, the VPC ID, the subnet ID, and the name of the service I would like to access. And it generates a lot of JSON, but there is one piece of information important in this JSON, so let's roll back. It's that one there at the top, the VPC endpoint ID, because you need to report that back to MongoDB Atlas. So I'm going back to the MongoDB Atlas console. I copy the VPC endpoint ID, I click Create, and after a few minutes, the status of the network connection will become available. And if you go to the AWS console, you will see that on the AWS console, the status will turn to green, available as well. And starting there, you have a private network link in between your network on your AWS account and MongoDB Atlas. So I create a database, I choose connection type, private endpoint. I copy paste the Mongo shell command because I never can remember all the parameters. And I go to my AWS console. I create a virtual machine, an EC2 instance in the same VPC. I connect in the same network. I connect to it using System Manager, and I try to connect to the database. It asks me for a password, and yes, it works. I can connect from a virtual machine in my network on AWS to a MongoDB Atlas. I can see all the databases that are there, all the connections. So yeah, I have the network connection in between my AWS account and MongoDB Atlas. Great. So that's the first pain point of integrating the two worlds, your AWS account with MongoDB Atlas, having a private network connection. That's done. Now we can go into some hardcore encryption stuff with KMS. So what else can we do? If you think about the database security in general, there are typically three pillars. One of them is access control, username, roles, who can see what and when. I'm not going to talk about that. There is network. We talked about that already with a VPC private link. And then there is the storage, how the data are stored on the server side. Is it encrypted at rest? Yes. But you can also encrypt at the field level. So your application can choose selected fields in your records and in your documents and encrypt these fields before sending them to the database. That way, even if an admin has access to the database, maybe an admin from your company, not necessarily a bad guy, even the admin of the database cannot access the encrypted data there. And of course, you're not going to encrypt the whole document, but just a sensitive piece of information you want to hide, like email address, social security number, credit card number. In this example, I'm going to encrypt a credit card number. So my super complex document I'm going to work on for this demo has a name and a credit card number. Name is Seb, it's me, my credit card number is there, 1, 2, 3, 4, 5, 6, 7, 8. I guess it's, well, you guess probably that it's not the correct one, but it's just for the demo. And what I'm going to store actually in the database is this. Look at the credit card there. It's encrypted. It's a binary buffer. So it's a suite of bits and bytes that has been encrypted with an encryption key. And I will do that on the client side. A key, I pronounce the word. To encrypt, you need a key. So where is this key coming from? And how are you going to secure the key? The first thing you have to know is probably you are not going to use one key. You are going to use a lot of keys. There are multiple strategies for keys, but you might store or use one key per customer, like all the fields related to SEP will be encrypted with the same key. Or you might choose to have one key per field, like my credit card will be encrypted with one key, and my social security number will be encrypted with another key. Multiple strategy you choose. The more key you have, typically the more secure is the solution, because if someone managed to hack one key, he will be able to decrypt only one field for one customer and not the entirety of all the fields for all your customers. But that gives us another problem. Where do I store these keys? And how do I store them? So best practice from the industry is to use a master key and to encrypt your data key with the master key. I'll try to pay attention to the words here. We have data key for field level or customer level encryption, and then the master key that allows to encrypt all these data key. But it's a chicken and egg problem. Where are you going to store the master key, and who can access the master key? So to help to solve that problem, there are a couple of hardware-based solutions. Maybe you heard about hardware security modules. These are security modules, hardware that are protected. So if someone tries to tamper the device, to access the memory or the CPU of the device, they will self-destroy. So we have a service on AWS called AWS Key Management Service that allows you to create master key, to generate data key, and you have the guarantee that the master key will never leave the service in clear text. It might leave the service for replication reason, but not in clear text. So the idea is to create a master key once, or a couple of master keys, one per table, for example, or per application, but you create a couple of master keys on KMS. The master key will stay on KMS forever. It will never leave there. And the encryption and decryption operation will happen on KMS itself. So if you need a data key, you can call an API saying, hey, Mr. KMS or Mrs. KMS, can you generate a new data key for me? And KMS will generate a new data key and will give it back to you in an encrypted version so that you can store it somewhere, and a clear text version so that you can use it to encrypt and decrypt your data. You control the access to KMS. So if you know a bit about AWS, there is something called IAM, Identity and Access Management, where you can define policies, so permissions to access the keys. You define who can access which key under what condition. IP address, time of the day, principal. It might be a virtual machine, a Lambda function, a user. You define who can access the key. And you don't have to trust us. All the access are logged inside a service called CloudTrail, so you can audit the access to the key and see exactly who access what and when and under what conditions. So everything is logged inside CloudTrail. And once you know that, the rest is pretty much, it's easy. Because MongoDB provides a Mongo driver, as you know, in a dozen different programming languages. And that Mongo driver does all the heavy lifting for us. So we just have to tell him, hey, this is the key, this is how to access to KMS. And all the low-level details of encryption and generating the data key and storing them, it's actually hidden by the MongoDB driver. So the MongoDB driver, on one side, will talk, of course, to the database, Atlas in this case, but will also talk directly to KMS using the API of KMS to generate data key and to crypt and decrypt data key as needed. So let's see that at code level. Let's see that in details in the code. You, as a developer, you have two things to do. You have to create the master key. MongoDB driver will not create the master key inside KMS. And you need also to create the policies, so the permission to use that access key. So how to do that? You go to the AWS console, you create a new key, you give a name to your key, a master key. I'm talking about master key here, MongoDB master key. Next, you can choose what principal will be authorized to administrate your key. You can define a key level usage permission as well. It generates a policy for you, and you click finish. Here I have two keys. The one I just created is the second line, MongoDB master key. I copy-paste the ARN. The ARN is the AWS identifier for that key. So it's a unique, globally unique identifier that references that key. It has my account name, the region, and other information there. That's the unique ID for this key in the world of AWS API. The permission I'm going to use for my application to access that key is very simple. A permission, if you never saw a permission document from AWS, don't be afraid, it's not very complicated. The effect is allow here. I can have allow or deny. The action is the API that I authorize, so decrypt and encrypt. And the resource is the master key, so it's the reference that I just copy from the console. So basically, whoever received this type of permission will have the authorization to decrypt and encrypt data, typically a data key, with the master key that is given as a resource. That's a permission. I'm going to attach that permission to a role, an IAM role, and the role is the vehicle that allows me to distribute that permission to someone or something. I can attach a role to a virtual machine, I can attach a role to a Lambda function, I can attach a role to an individual, me behind my laptop, for example. And so I will have the permission to decrypt and encrypt the data key. Oops. Next, yeah. So that part is done. I have configured KMS, I create a master key, and I create a policy, a role that allows whoever will receive this role, will assume this role, to access the encrypt and decrypt operation with the key. Do I still have everybody with me there? Because now we are going to enter in the code and go into the details. The AWS side of the things is done. We have the network, we have the key, we have the authorization. So now we are going to look at the code that we need inside our application. And basically there are two parts of the code. The first part, at application level, is to create a data key to encrypt your document or specific fields of your document. The second part is, of course, to encrypt the data that you want to encrypt, and then to send it to the database for storage. And you need to store the data key as well, so that later you can decrypt the data that has been encoded with that key. So let's start with the data key management. Again, it looks complicated because there is a lot of arrows. It's not complicated. On the left side, you have your client application, the application you're currently writing. And the little green rectangle there, it's the MongoDB driver. It's actually native code plus a daemon, a common library used across all different languages that you need to install on the machine where the client application will run. That driver, when you ask to create a data key, will actually call AWS KMS to say, hey, KMS, give me a data key. And as I said before, KMS will return the data key in clear text, so that you can use it directly to encrypt something, for example, but also encrypt it with the customer master key, so that you can store the data key somewhere with your data. MongoDB uses the concept of a key vault to store the encrypted data key. Again, there's multiple strategies to store the data key. It might be in the same document as the one where the encrypted field is, or in the same collection, in the same database. Here it's a different collection in the same database, but you can have different strategy. You can use a different database, for example. But the idea is that the data key, the encrypted data key, would be stored in MongoDB just alongside the rest of your data. So the client application asks for KMS to generate a key. The key comes back in two versions, clear text and encrypted. The encrypted is stored in the key vault, and the clear text version is used to encrypt or decrypt data. In most of the MongoDB documentation that I read, the call between the client application and AWS KMS is authenticated with an access key and a secret key. And in the code sample that I found, or in the documentation, the access key and the secret key is hard-coded inside the client application. An AWS access key and secret key, if you are not familiar with that, it's like a username and password. This is what authenticates you and grants you access to KMS. So the best practice, of course, is to never, 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 under no circumstances, never, I know I'm insisting a bit here, hard code a user access key and a secret key inside your code. Because sooner or later that code will be shared with someone, you are going to do a git commit, git push without thinking about what is in your code, and your access key will be there, maybe on GitHub or GitLab or unfriendly places, at least for secrets. So in the demo I built, I chose a different approach. I ask the application to assume the role that we wrote, that I showed you before. And it's not very complicated. It's only like, I don't know, 10 lines of code. You need another AWS service called STS, Security Token Service. And basically what the application says there, it creates an STS client and will call, roughly here, a command called assume role. So it will ask to assume the role that we have just created. So it prepares a couple of parameters. What is the role I want to assume, the name of the session, the duration, and the STS client sends the assume role command, and when it returns, I receive a temporary access key, secret key, and session token. These access key and secret key are limited. They are limited in time for the duration that we include there. It's 15 minutes by default, 900 seconds. And it's limited in scope, only for the permissions that we have defined in the role. So even if these leaked somehow, it's only valid for 15 minutes and only for two very specific operations, encrypt and decrypt on one specific master key. So it's not like hard coding an AWS access key and secret key in your code. So that's the way the client application acquires an AWS access key and secret key. And then it needs to configure the KMS provider on the MongoDB driver side. Basically, the KMS provider requires the same information, an access key, a secret key, a session token, except that it's wrapped into an AWS object, and that's why you have the little AWS column there, because MongoDB drivers support multiple KMS providers, not only AWS, but also Azure and Google. Once I have that, the rest is pretty much the same. First, I create my MongoDB client with the connection string. I connect to the database, and I wrap that MongoDB client into an encryption client, the client encryption object. So the client encryption object receives 3 parameters: the client that I just created before, the name of the key vault namespace, so where to store my data key, in which database collection I'm going to store the encrypted data key, and the name of the KMS provider able to generate and to encrypt the data key or to decrypt the data key. So these are the 3 parameters the client encryption requires. Once I have that, I can use the client encryption object to request a new data key. So I can call the method create data key on the AWS provider. I give as a parameter the reference to the master key. I want my data key to be encoded with that master key, the one that I created on the AWS side just before. And I can give an alternate name, like a friendly name, so that I can remember why that key was used. If I look at the key vault just after that, I can see that there is a new entry in the key vault. And the third line is the most interesting one there. There is key material. This is the encrypted data key that has just been created for me and stored on the key vault. And in the bottom part, you see the reference to the master key. What was the master key that has been used to create this data key? Still with me? Because now that we have a data key, we can encrypt and decrypt our data. That's the last step of the demo. And again, the MongoDB driver does most of the heavy lifting for us. So whenever it needs to encrypt or to decrypt the data, it will fetch the data key from the key vault. The data key in the key vault is encrypted. So we'll send the data key to KMS, AWS KMS, to say, hey, can you decrypt that key? KMS will return the clear text data key. And once we have the clear text data key, we can encrypt or decrypt the data inside our document. You can have manual or automatic encryption and decryption. For this demo, I choose to use manual encryption just to go through the step and see how it works. But I will show you also automatic decryption there. So let's first encrypt my credit card, because at the end, we are there for that, just to encrypt my little field credit card on the initial document. So I create a MongoDB client connection string for automatic encryption and decryption a bit later. I give directly to the MongoDB client the reference to my key vault and my KMS provider. Once I have my MongoDB client, I create a client encryption object just like I did before. I pass the connection, the name of the key vaults, where to store the data keys, and the KMS provider that is able to generate and decrypt these data keys. I have my credit card field, 1, 2, 3, 4, and I call encryption.encrypt. I pass the credit card. I give the name of the key I want to use for the encryption, and I give the name of the algorithm. You have to go to the documentation to find this one. You cannot figure that by yourself. Note about the last word there, deterministic. It means that the same key plus the same data will generate the same encrypted result. This is very convenient if you want to search by credit card later. Non-deterministic means same key, same data, different result every time you encrypt. It's convenient if you are not trying to search on the encrypted data later. So my person object will have a name, and the credit card will be the encrypted version of the credit card. And after that, it's regular code that you are all used to write db.collection.insert one person. And without surprise, the person has an encrypted credit card. And to read back, still looking at the time, I still have 5 minutes. So to read the data back from the database, I'm going to use automatic decryption. Means I don't need to explicitly, me as a developer, I don't need to call encryption.decrypt. The MongoDB driver will figure out automatically that there is a field encrypted in the document that it's retrieving, and will fetch the correct key and decrypt that field for me. 0 line of code to write on my side. So I want to do a search, and remember, I can do a search because I use a deterministic encryption algorithm. So I define person as having a credit card which is the same encrypted credit card that I had before. And then on the MongoDB driver, I call db collection find one person. And the search will be done on the encrypted version of the credit card, but the result that the driver will return to me is the clear text version. We have 1, 2, 3, 4 back there. It's a bit magic. So I show you how to create a data key, how to encrypt the data key with the master key that you have securely stored on AWS, and how the data key can be stored in a local database, a key vault, and is the driver doing that automatically for you. I show you how to encrypt the data and how to decrypt the data at field level. So 3 things that we talked during these 30 minutes, or 26 minutes exactly. How to use a private link, so a private network cable between your AWS network and the MongoDB Atlas network in the AWS cloud of MongoDB. How to configure KMS and IAM to create a master key and restrict access to that specific master key. And then how to use the MongoDB driver to automatically or manually encrypt and decrypt data at field level inside your document. And if you want the full version of the sample app, just go to my GitHub repository. You have separate TypeScript shell for each of the different steps, like create a data key, encrypt, decrypt, a couple of instructions in a README file as well, how to set up the MongoDB driver daemon, the encryption daemon. If something is not working for you there, just log an issue and I will be happy to help you. I see all the camera are done. See 1 or 2, 3. And we have 3 minutes for questions. Give me your feedback. It takes 2 minutes to go there. It's a 3-question anonymous survey, and you might receive a $25 AWS service credit voucher that you can redeem on your AWS account. So if you want to try that for free without spending anything on your credit card, just give me your feedback about this session. Thank you.
Thank you, Sébastien. That was a very complex subject made very simple. Thank you. I think that's one of the best ways I've seen that described. And it's always great to have AWS with us as well. Thank you very much.
Thank you.